Let's talk about something very important in risk management, backtesting VAR. So we already know that value at risk, or VAR, predicts the worst loss we might face on a normal bad day. For example, a 95% one-day VAR of rupee 40,000 means we expect that most days we won't lose more than rupee 40,000. But here's the big question. How do we know this prediction is actually correct? Because honestly, VAR is just a model, and models can be wrong. That's where backtesting comes in. Backtesting simply means comparing what the VAR model predicted with what actually happened in real life. It's basically a reality check. Think of it like this. VAR makes a promise and backtesting checks whether that promise was kept or broken. Now suppose your model says you are using 95% confidence. That means losses should exceed VAR only 5% of the time. So if you test this over 100 trading days, you should see about 5 days where the actual loss is bigger than the VAR number. Not 15 days, not 0 days, around 5. Whenever the actual loss becomes larger than VAR, we call it a violation or an exception. That's simply a day when the model failed. For example, if VAR is rupee 40,000 and one day you lose rupee 55,000, that day is counted as a violation. So during backtesting, we basically count these violations and study their behavior. Backtesting is extremely important because without it, VAR is just theory. A model might look perfect on paper, but completely fail during market stress. That's why regulators like Basel require banks to backtest their VAR models regularly. It helps confirm whether the model is realistic, reliable, and safe to use. Now in practice, there are two famous statistical tests used for backtesting, the Kupiec test and the Christoffersen test. Together, these two tests tell us whether the VAR model is trustworthy. First, let's understand the Kupiec test. The Kupiec test is also called the Proportion of Failures test, and it asks only one simple question. Did the number of violations match what we expected? It doesn't care when the violations happened. It only cares about how many happened. So if you're using 95% confidence, you expect 5% violations. That means in 100 days, around 5 violations. In 250 days, around 12 or 13. If the actual number is much higher, say 15 or 20, then clearly the model is underestimating risk. Losses are happening more often than predicted. On the other hand, if there are almost no violations, maybe 0 or 1, then the model is too conservative and overestimating risk. That's also not ideal because it makes the bank hold too much unnecessary capital. So the Kupiec test simply checks the quantity of exceptions. You can think of it like counting how many times the model failed. If the count is about right, the model passes. If not, it fails. But here's the catch. Even if the number of violations looks perfect, something can still be wrong. Imagine you observed exactly 5 violations in 100 days, which sounds correct. But what if all 5 happened consecutively on 5 days in a row? That's scary, right? That means during one stressful period, the model kept failing continuously. The risk clearly increased, but the model didn't adapt. Kupiec would still say everything is fine because the count is 5. But in reality, the model is missing something important. This is why we need the second test, the Christoffersen test. The Christoffersen test checks whether violations are randomly spread out or clustered together. In a good VAR model, violations should be independent and random. One bad day shouldn't automatically mean the next day will also be bad. But if violations start appearing in clusters, it suggests the model is not capturing changes in volatility or market stress. So Christoffersen looks at the pattern of violations, not just the number. If losses tend to come back to back, the test fails the model. If they are nicely spread out over time, the model passes. In simple terms, Kupiec checks how many times you failed, while Christoffersen checks how those failures are distributed. A nice way to remember this is with a weather forecast example. Suppose the forecast says there will only be 5 rainy days this month. Kupiec checks whether it actually rained about 5 days. Christoffersen checks whether those rainy days were spread across the month or if it flooded for 5 straight days. Flooding means the forecast was clearly unreliable, even if the total number was correct. In real life, banks always use both tests together. First, they check the frequency of violations using Kupiec. Then they check the independence or clustering using Christoffersen. If both tests pass, the VAR model is considered reliable. If either test fails, the model needs to be recalibrated or improved. So at the end of the day, backtesting is simply a truth test for your VAR model. VAR predicts the risk, and backtesting verifies whether that prediction matches reality. Kupiec makes sure the number of exceptions is correct, and Christoffersen makes sure those exceptions occur randomly rather than in dangerous clusters. Together, they ensure that your risk model isn't just mathematically elegant, but actually works in the real world.